So in this world, everything is about balance.
From the decomposition of dinitrogen tetroxide to our bodily chemical reactions, balance is necessary.
Hi, I'm Sarah,
And I'm Vincent.
And this is What's That Chemistry? In today's episode, we will be diving into the colorful world of chemical equilibrium. The word equilibrium has been thrown around quite a lot in our science classes. Chemical equilibrium, though, may or may not be as familiar.
To understand it, you know what to look at. Molecules. Imagine that these sad faces are molecules of the compound sadness, while the others are that of happiness. At first, there are numerous sad faces but no happy ones. But as this reversible reaction goes in the forward direction, a lot of them get converted into happy faces, and some happy faces also get turned into sad ones over time.
So when exactly does this system achieve chemical equilibrium? It is when the rate of the forward reaction equals the rate of the reverse reaction. In this scenario, it can be described as having the same amount of happy faces and sad faces transfer places at the exact same time. This analogy also happens in chemical reactions at equilibrium, in which the rate of both products and reactants are equal. Because of this, the amount of both compounds will now remain constant over time.
But don't be mistaken, chemical equilibrium is in a dynamic state, not a static one. Although it may seem like there's nothing going on in the system if you look at it from afar, take note that the molecules of both compounds are still constantly undergoing a chemical reaction, in which the rate of the forward reaction is just equal to that of the backward reaction, making it look like a static condition. Simply put, the molecules don't rest and the reaction hasn't come to a stop.
One more thing though. Actually, this direction isn't the sole path to achieve equilibrium, as equilibrium can be approached from either direction. Earlier, we started off with an initial maximum amount of sad faces and zero happy ones, which resulted in the conversion of sadness molecules into happiness molecules in the forward direction to achieve equilibrium. But what would transpire if the initial concentrations were reversed? Well, the reaction would then proceed in the backwards direction and the happy molecules would become sad molecules, still achieving equilibrium later on. So by knowing all these chemical equilibrium concepts, we get to have a greater understanding not only of ourselves, but also the world we live in.
That's it for today's episode. Thank you for tuning in to What's That Chemistry?
See you next time! Bye!